So hey guys, so today I would be discussing about the continuity and differentiability concept. So generally students find it very difficult to understand, and today I would be telling you in very simple manner. So let's begin from here. So what is continuity? So continuity is something I would explain with the help of graph. Okay. So suppose this is a y equal to fx is a function. Okay. We have this x-axis, y-axis. Okay. Now if I make a graph, suppose I am making a graph. Okay, just see how I am making a graph, right? If I am making a graph and my pen or whatever it is, if I am not losing the contact of this pen and this board, then it will be continuous. Suppose I have loosened the contact of this pen and this board here, and again I'm just making it from here. So in this area, okay, it is discontinuous. So continuity is simply anything, any graph which is going in a continuous manner. It is not breaking anywhere. If a graph breaks, then it would be discontinuous. Whether it is, if you are saying like if I can make a graph this way, so it is not breaking anywhere, right? But if I am making a graph in this way, so it is breaking in this part, in this part. So if I say this is the first part, this is the second part, so this function is not continuous in the first and second part. Okay, so simply continuous means making a graph in a continuous manner. Okay, now let's discuss about differentiability. Okay, so suppose I am making a function in this way. So what is differentiability? Differentiability is something where the derivative of a function does not exist. So here if I say what is derivative, I have already told you in my previous video. So derivative is a tangent at any point. Suppose this is a point and I have to make a tangent over here. So if I am able to make a particular tangent over here, then its derivative exists. But if I say what is the tangent on this point, suppose this is the point B. So what's the tangent at this B point? So I would be able to make a particular tangent here. Suppose I have made like this, but I can also make like this. I can also make like this. So from this point, I am making more than two tangents. And if you see it, then you can say that you can make infinite number of tangents at this point. So what does it mean? It means we are not able to make a unique tangent at this point. So that means there is not a unique derivative here, or the derivative of this function at this point B does not exist. So here at point B, derivative does not exist. So at B point, derivative not exist. So where the derivative is not existing, that point is non-differentiable. Here the differentiability would not be existing. Okay, so at the B point, the function is non-differentiable. It is not differentiable because the derivative does not exist, as I have already told you. So this B point is non-differentiable. Okay, so now I would give you a simple example with the help of which whatever I have explained you about the continuity and differentiability, you will be able to understand both the concepts in one example. So suppose we have function y equal to mod x. So if I break this mod x, then y equal to x if x greater than 0, and equal to minus x when x is less than 0. So it's a breakage of mod x. Okay. Now when I will make this graph, sorry, when I will make a graph of this, its graph is like this. Okay. You can make it on a graph paper. You will see that the graph is like that. For x greater than 0, y equal to x, y equal to x is this line. For x less than 0, y equal to minus x, y equal to minus x is this line. Okay. So if I see is this function continuous on the domain of this function? If I see the x-axis, so is it function continuous for all the values of x? So what you would see according to the concept whatever I have explained you. So according to that, this function is continuous because it is not breaking anywhere. You're getting my point? It is not breaking anywhere. So that's why this function is continuous on all the values of x. It is never ending. It is never ending. For all the values of x, from minus infinity to infinity, this function is continuous. Okay. Now talking about differentiability. If I able to make the, if I would need to make the tangent over this point, then I would, this would be the tangent. This point, all the points there would be a tangent, that is this line. This line would be a tangent of all the points here. If suppose this is A point, this is B point, this is C point, then at A, B, C point, the tangent is same, this. And this is a unique tangent. We cannot say that at A point there is some different tangent, or at B point we are able to make two tangents. So a unique tangent is going on at all the points A, B, C. But if I say here, it is a pointed one, right? So here at the pointed one, if I want to make a tangent, then what I will see? I will see that I can make infinite number of tangents over here. So the derivative of the function would not exist here. So that's why at this point x equal to 0, the function is non-differentiable. So you can check any of the function by making the graph. You can check whether the function at any particular point is differentiable or continuous or not. So in the NCRT as well and in the different examination, if you will see that different complex functions are coming and you are applying the different algorithms or formulas with the help of which you are able to come into the conclusion that this function is either continuous or differentiable. But whatever the concept I have explained you by making the graph only, within a second you can you can get an idea whether the function is continuous or differentiable. So I hope that this concept is clear to all of you. And if there is any confusion within this concept, then you can ask me in the comment section. So thank you guys. This is all from my side.